I came to a certain abrupt closure because I was running out of time. So, let me very quickly review the set of rules for insurance company which we are looking at, and we started off with a set of 5 rules, and we found out there are 4 conditions. Then we mapped it onto decision table, and then from that the decision table we converted to a elementary rule decision table and entered into a Carnot map. And after having entered into Carnot map, then we use the Boolean algebraic simplification methods to simplify the conditions and for the action A1, because there are only 2 actions in this case, ensure or don't ensure. If A1 is not true, then A2 is true, and vice versa. So, having done that, we got the Boolean expression for A1 as C3 or C2 C4. Then we mapped it on to a decision table again, and this table we found has only 3 conditions and 2 rules, and so the rules from 5 get reduced to ensure if married or male over 30, and see, and that is all. I mean, married, first rule says ensure if married, and second one says if male over 30. So, that is essentially you can make it as 2 rules if you want to say. One says ensure if married, 2 ensured if male and over 30. Now, the point I was making at the end of the lecture last time is that the reason why such redundant rules come in things like insurance policies, and in fact even many government rules and other income tax rules and so on, is that year after year they go on amending the rules, adding new rules, and without really looking at the fact whether the new rules which they have added is contradictory to the old rules or redundant and so on. So, they organically grow without any clear logical thinking in terms of the earlier rules, unless somebody points it out. So, when you do an analysis, and particularly when you do an analysis based on Boolean algebra, it turns out to be quite obvious that the rules which are originally suggested in this particular case are that it has grown to such an extent that whole lot of redundancies have come in, and that all conditions are not required. So, that is the reason why it is very important when you are given a set of complex conditions and rules and so on as a written word statement, you have to go through that word statement again and apply some logical methods to find out if there are rules are consistent, any contradictions are there, if there is ambiguities or contradictions are essentially ambiguity, or there is some redundancy, extra unnecessary rules are there. So, that is the main purpose, and that is what the decision table methodology allows you to do, to be able to remove such incorrectness in the given word statement of a problem given by a customer. In fact, many companies also have similar very complex business rules. In fact, insurance rules here is a very simple example of an insurance company giving these rules. Similarly, banks have their own rules, and most organizations have certain business rules which are to be followed, which are to be reflected by an equivalent computer program, because ultimately the people are being removed and being replaced by machines which do these routine types of jobs. Okay. Now, I deliberately went to this example because it is very simple to illustrate as first example. So, let me go back to the original example with which I started. The original example with which I started was the example of credit card rules. In fact, we had this set of credit card rules put into a decision table. Then I mapped it onto a Carnot map, and I found that certain boxes have multiple actions and certain boxes are empty. One box is empty in this case. So, when there is empty, that means the rules are, there is an incompleteness and there are multiple actions in any particular box. It means that there are some kind of contradiction in the in the way the rules are formulated. Now, it may turn out that some of these contradictions may not occur in practice because of the fact that the conditions which could be in this case expressed as inequalities are not consistent. Like in this case, we found that the last C1 C2 y no cannot really occur because of the way in which the conditions are given. So, once we find out that cannot be given, that just cannot occur in practice, we cross those boxes out, saying that you do not have to really take into consideration those boxes, because no real data will ever occur which will lead to those rules. Okay, no data will ever occur. So, that means there are two advantages in this. When you take it out, that means you are essentially eliminating those rules. Secondly, those can be used in Carnot map reduction. In other words, they are so called do not care conditions in the Carnot map, and whenever there is a do not care condition is there, that means it does not really actually occur in practice. It can be used in minimization, that is the entire column is a neighbor of some actions. So, we can combine those actions, and the previous table we found that the box n and n, which is the corner box there, and then two other boxes n C1 C2 ny, C3 C4 ny and yy ny. These two boxes have multiple actions and they can really occur. In other words, they are not apparent contradictions like the last column, they are really real contradictions. So, we have to go back to the manager who made up the rules and say that there is a contradiction. I do not know whether to take action A2 or A4 in one case, or A1 or A4, or should I take both. Taking both is somewhat stupid, because there are two different letters in this case. The actions are send letter A, send letter B and things like that. So, I cannot send two letters which are probably contradictory to one another. So, the manager has to tell which of the actions or which letter has got to be sent. So, having discussed with the manager, I am assuming that we come up with this, that is, the manager decided that the blank has got to be filled by action A4, which is sending particular letter, that is action A4 really is send letter D. So, you send letter D, and in fact, in the other cases also send letter D, which is a letter D may be some kind of a common type of letter. So, that whatever it is, I do not know what the letter contains. So, anyhow, I am assuming the manager told that A4 is to be used rather than A1 or A2. So, I put A4 in both these cases and remove A2 A1. Now, this particular Carnot map has got only one and only action in each box, and it has all boxes filled up. That means, it is now does no contradictions, it has no incompleteness, and now it can really is logically a correct situation. So, I map this into onto a decision table. I end up with a decision table with how many rows? 12 rules, because out of 16, 4 are do not care. Okay. So, there are 16 rules, but then when you look at this map, we see that there is a possibility of reducing the number of rules, because there is a possibility of combining actions together to eliminate some conditions. Okay. So, in this case, we start off with the worst possible action, that is an action which has no neighbors with which it can combine. Okay. In this case, that is actually if you take A2, it is standing by itself. A4 can be combined with A4, this is also A4, A1, A3. So, it can't combine with anything. So, A2 has to have all 4 conditions specified. So, that is normally in Carnot map reduction you should start with the most unpromising box which cannot be combined with anything, because otherwise there is a possibility of by mistake using the same box in more than one combination, and so a redundant term will occur. So, the important thing to start with that. Then let us look at the next most unpromising one. A3 has no neighbor here, no neighbor here. This also has no neighbor here, no neighbor here. But this A3 and this A3 are neighbors, because as I said, the Carnot map can be thought of as wrapped around a vadai in both directions. So, that means that the top column, the top row and the bottom row are really neighbors. So, that means I can combine this and this, and normally people put a circle like this and another circle like this, okay, to show that these two can be combined. And if you combine it, C1 C2 is no y, C4 is constant at no, C3 takes on both values n and y. That means A3 is represented by C1 naught C2 and C4 naught, because it is constant. Okay. So, that is how I get that. Okay. So, after having combined these two A3, then I go to A4 has got lots of neighbors, looks like, and A1 also assumes to have lot of neighbors. So, let me just take A1. Okay. If I take A1, these 4 will combine. When 4 combine, we know that 2 conditions will get eliminated, isn't it? Well, so let us get back to this. Yeah, these 4. That means I just look at the column. In this case, C1 is constant at S, and C2 takes on both values. So, C2 will get eliminated, and C3 is constant at Y, and C4 is Y and N. So, C4 get eliminated. So, the A1 now would be, then one rule would be C1 C3. Okay. So, A1 will be C1 C3, that is one. The other A1 is sitting here. This A1 has got a don't care neighbor which can be combined with that. So, I can now take this 4, this 2 and this 2 and combine, because we can use the same action in more than one combination, one circle, or one what they call a cube in the Carnot map parlance. So, it can be in more than one and so I can combine this with this, and I will find now that C1 is constant at Y, C4 is constant at no, C3 takes on both values. So, it is actually A1 would be C1 and C4 naught, okay, C4 naught. Okay. So, A4 is combined, A1 is combined like this. Now, A4 these 3 are there, and there is one don't care. So, these A4 can be combined together, and so C1 C2 becomes irrelevant, because all 4 possibilities are covered, and C3 C4 is YY, that means NY, that means C3 not C4 is this 4. Okay. So, I combine these 4, and then one more, this A4 is left and this A4 is left. Now, what can I do? If I look at the neighbors, these two A4s has got this as a neighbor. So, this can be combined, and these two A4 can be combined with, no, there is no A4 here. So, I cannot really combine there. So, this of course becomes a 4 box, and this A4 I can combine like this. Now that these two therefore can be combined like this and with do not care, okay, both are do not care. So I can make a 4 box out of that, 2 4 boxes, that is one is this. This 4 box will again eliminate 2 variables, and one is C1 naught and C3 naught. So this will become C2 naught, C1 naught and C3 naught. Now if I combine this will become C4 and C2 naught, okay, because C1 takes on both values. So now I combine. So I will just show them in summary. See, I got for C1 A1 C1 C4 naught or C1 C3 and A2 C1 naught C2 C3 C4, because all 4 were there. A4 had essentially 3 rules and A5 had essentially 1 rule, okay. So this is essentially what happened, and now I can map that onto the decision table again, that is, take each one of them and map it on, and wherever a variable does not occur I put a do not care, wherever a variable occurs I put the yes or no, okay. Having done this, I end up with a set of rules which are now total number is 2, 4, 6, 8 rules instead of 12. From 12 it came down to 8 rules and a lot of do not care conditions. That means when I write a program, those conditions need not be tested, okay. So it will become somewhat more time effective. There are in fact computer programs available which will reduce or make an equivalent program corresponding to this decision table, which is optimal in some sense. The optimality consideration in this case normally is taking which program, so because this same table can be mapped into different programs, it is not unique. So which program will be the one which gives minimal time of execution is one criteria which normally people use. For that I should know more information, namely what is the frequency of occurrence of each rule. If the frequency of occurrence of each rule is given and the time to test each condition is given, then there are optimization methods which exist to kind of reduce this table to an equivalent program which is minimal runtime program, okay. In fact these programs are actually automated. In fact provided this data is given to you, time for testing conditions will be easy to infer from the complexity of the condition, okay. But the frequency of occurrence of rules may not be always easy to get, but normally what they do is when the same program, like say a payroll program or some other program of a similar nature which is repetitive, which is run very often, if it is run over a period of time, then the frequencies can be found out empirically. That is, you can actually count how many times these particular rules are fired, you might say, and then count and using the total number of experiments made, you might say total number of runs, I can find out an empirical probability. An empirical probability which is a reasonable approximation of the true probability depending upon the number of times I run, okay. The larger the number of times I run, the probability will tend towards the true probability. But I think I am not going to get into this optimization issue because little bit out of our range in terms of the fact that it will take 2-3 lectures to explain that, because there are many methods available. There are certain optimal methods which you can guarantee are optimal, which use things like branch and bound and so on, mostly operated research techniques, and there are some heuristics. Heuristics means you get a program which is almost minimal time, but not guaranteed to be minimal time. And that is also all right. The reason why one looks for a heuristic is that the amount of time taken to come up with a heuristic is much smaller than the amount of time required to do the true optimization, and so there is a trade off again. And so people normally look at heuristics provided one can compare what the time given by this heuristic is related to what is optimal. If it is close enough, okay, then it is and the heuristics is very simple, then one would use a heuristic, and that is what is normally done. Mostly heuristic methods are used. What I mean by heuristic method is a method which is approximate, which cannot be guaranteed to be optimal. But then in a situation where the probability itself is not accurately known, a little bit of error in heuristics does not make any difference. So, in practice the optimality may have no meaning, because you start with the data itself which is not reliable. Okay. And so, there are many situations in computer science like this. You could really find out optimal methods, but the optimization will take a long time, the computer optimization, and you also find heuristics which will take less time. And depending on the situation, depending on what data you have available, if data itself is not available with any great accuracy, there is no point whatsoever in going for a true optimality, because it is very nice to have a PhD thesis with a true optimal solution. Okay. That is what gets you the PhD, but the heuristic is what is more practical in many situations. Okay. Because it does not mean that PhDs are not given for heuristics. It is given for heuristics provided the heuristics is a good heuristics, and you can show that it is close to the optimal, in which case I think you get a pat in the back saying that you have come up with a much less complex problem. It is not an n cube problem, but it is a order n problem. It is an order n cube problem. That means the solution is going to take much less time, depending upon, see, in this case the order n will depend upon the number of conditions. Okay. Of course normally the condition in this case is quite small. As I said, normally you would like to break it up into smaller ones, because we have to understand it. Okay. So that is the point, but the reason why I said all this is because the advantage of with this methodology is that programs also exist, good heuristic programs also exist to do an automatic conversion, and your manual job is one of making sure that there are no contradictions, incompleteness, and so on. So, if you say that it is logically correct, that is the very first step. Once it is logically correct, then you can go ahead and write a equivalent program. Okay. And in fact, this is a much better method than using test data, because test data will not guarantee the correctness. Okay. It only will not show the absence of errors. Okay. It will only show the presence of errors. Okay. That is a famous Dijkstra statement about the need for proof of correctness. So, this is some kind of a proof of correctness which we have used, okay, but not as esoteric as situations where in loops and loop invariants and so on. I mean, of course, the question of esoteric or not depends upon how you are taught that subject, but basic principles are fairly straightforward in terms of the checking the correctness of program as you write programs. Okay. And if you follow them strictly, then you will end up in a situation where testing will become redundant. So, in this case testing will become redundant if you follow the rules very carefully. Okay. Now, I have really completed the part related to decision tables. Now, I will go to the next part of the talk called decision trees. Decision trees is somewhat like flowchart. It is a sequential testing procedure of conditions, and when sequence of testing conditions becomes important, then you use it, and it is more procedural. That is, in other words, the order of testing conditions is pre-specified, unlike in the decision table where the order is not specified. The conditions can be tested in any order, okay, and that is how you put them in one table. But the advantage of conditions being put in any order is what helps in optimizing the program, which is going to which results from the table, okay. Whereas in this case I do a pre-decision of testing in certain sequence, and it is necessary in some cases. See, like let me take an example. An officer sends his assistant to the railway station to book a ticket on a train, and he gives the following instructions: book a second AC on for some arbitrary date I have checked 4804 if available. If it is available on that day, book it, else book second AC on next day. If both not available, book by sleeper on the 4th on the earlier day, and if not available, then book it for the next day by sleeper. If sleeper is also not available for 5th, then maybe there is no point in my going on the 6th, so I decide that return, come back. If you do not say what to do in that case, the assistant will go to the railway station, and he will find out that the AC first second class is not available on 4th and 5th, sleeper is not available on 4th and 5th. So what will he do? He will just stand there. If he is stupid, if he is a robot, if he is intelligent, he will phone back the boss and say, sir, both days not available, what do I do? Okay. Then the boss has to tell that you return or book on 6th or whatever it is. In other words, the rules which are given, word statement rules which are given, normally people are not all that careful. They just take the last one, and in both cases do not occur. What do you do? They do not really say that, because they assume that at least sleeper will be available, and they send a person to book. See, that is what happens. So in this case, then the sequencing is important, because if AC second class is available in the 4th, I have to book it right away. Okay. C1, so the condition C1 in this case, which is AC second class ticket available on 4804, if it is true, book second AC. If it is not true, if it is not available, then find out if AC second class available on the next day, and if it is available, book, else you look for a sleeper and book sleeper, else you go next, and if it is available, book for a sleeper. If nothing is available, then you return. Okay. So this is where what I mean by the fact that the sequencing is important. Unlike if you put in a decision table, that means you can turn it around in any order, and so the DT is not really valid in such a kind of situation where sequencing is important. So sequencing is important not only in such human situations, but in many process control computers. What you try to do is to test various types of parameters of a process, like temperature, pressure, and so on, and they normally are tested in some sequence. Okay. And so there are sequential systems which are there to make sure that the correct sequence is followed. So they are all called sequence controllers and so on. Sequence controller is a very big area in instrumentation, okay, and designing sequence controllers. But in any case, I think the point is decision trees are a lot more useful if you are designing sequence controllers, which will occur in embedded systems, or if you are looking at word statements where the sequencing is important from the point of view of the semantics of the problem, the meaning of the problem. Now the decision trees are need not necessarily have just yes no answer. Okay. You can have a condition which has multiple possible answers, like in this case the I am just defining. Decision trees are drawn from left to right. Circles are used for conditions. Conditions are labeled with what the conditions represent below that, because you don't want to clutter up that particular tree. And then yes or no is what is the two results. But the condition need not necessarily be binary. So you suppose you are in an exam result, if it is greater than equal to 60, if you give grade A, and if it is greater than equal to 50, grade B, and so on, you can give A, B, C, but it is less than 40, grade F. Okay. So this conditions got 4 different branches which come out of it. Okay. So that is also allowed in decision trees. That means it is not only a binary decision tree we are looking at, it is a decision tree with multiple branches which can come, and each branch can lead to a different node, and that can in turn lead to multiple branches. Okay. Now I am showing a decision tree corresponding to an earlier slide, namely the discount rules which are there. The discount rules, let us just go back and yes, product code 1, customer code ABC, and order amount is a mixed entity decision table which I had, where the actions were giving discount, and then I had the product code 1 or 2, 1 in this case 1 yes or no. So I am assuming 1 or 2 can be used, and there are 3 possible customers ABC, and order amount is the third one. So this is what I have converted tree. Okay. If product code is 2, then discount is 5%. Okay. That's what those. I think I would urge you to go back and put that DT in front of you and go through it. I have a problem in the sense that I can't accommodate both of them in one PPT. Okay. So if it is 1, then you find out customer type ABC, and then find out if the condition C3 is about how much of order amount is there. The order amount is above 500, discount 7.5%. If it is below, then discount 5%. Table is now reflected as a tree. Now I have a priori in this case decided to test condition C1, C2, C3 in that order. Okay. But it need not be. As per the DT rules, I can in fact start with any one of them. Okay. But this looks more logical, and so it is easy to explain also. That is why I did it this way. So, the reason why I put this is that the tree can have, as I said, not necessarily just 2 outputs from any circle. It can have multiple outputs. Okay. And that is what shows here. Some places there are 2 outputs, and some are there are. So the other one which you had is that about the carbon content less than 0.7, Rockwell hardness greater than 500, tensile string greater than 3000. We had a decision table there, but we found out that if the yes, no, yes, if the yes, 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 no, and SS, no, and S is followed, then there are grades given. But suppose it happens to be say the answer to C1 is no, then and C2, no, I think there is an error in this. Actually this should be second circle should be C2, and third circle should be C3. There are three different conditions which are being tested, C1, C2 and C3. Okay. And but here again the fact that there are certain combinations of conditions, in this case SSS is specified, but suppose no SS is there. There is no for C1 no, C2 yes and C3 yes, no SS is specified, then what do? Is clear in the decision table, but it is not clear here. So the completeness of the decision table can be checked very easily, whereas this is because like a flow chart I cannot check completeness, because having started test with say condition C1, then the only other alternative is to test condition C2 next, because the sequencing is there. So, at C1, C2, C3 in their order, and so we cannot really find out the error in the decision tree. Now, let us compare the three methods. We had three different methods of specifying processes. We started this module with process specification. And we first looked at structured English, then we looked at decision tables, then we looked at decision trees. So, there are three different ways of actually specifying processes, and the question which arises is that which one would I use, under what conditions, and what are the advantages or good points and bad points about these particular methods. Now, the criterion I have compared are isolating conditions and actions. Which one of them isolates conditions and actions better? Which one is good at sequencing conditions by priority? Which one is good at checking completeness, contradictions and ambiguities? In other words, the logical correctness of a set of conditions. Now, structured English is not good in isolating actions and conditions, because they are all mixed up in that process statement. Okay. Some conditions are checked, and then some actions are taken, then some other conditions are checked, and so on. And it is good for sequencing conditions by priority, because when you write the process specification in some sequence, by implication you are saying that certain conditions that we tested in a certain order. And for sequencing, DTs are no good at all, because we are assuming that there is no sequencing involved as far as the conditions are concerned. The only place where sequencing is become important in the decision table is in terms of linked decision tables. When you have a linked table where one table leads to another table, then the order of linking becomes important. So, there could be some situations where a whole set of complex rules are given, you parse that rules. In other words, parsing means kind of reducing it to a set of consistent set of rules. Okay. And so, when you do a parsing of this into a set of consistent set of rules, then you come up with a linked table, because if you did not parse it, then the number of conditions in one table can become enormous. And the advantage of a table in terms of completeness checking and ambiguity checking and contradiction checking and all that will be difficult, and it will become unwieldy. That is the reason why we kind of parse it and make it into smaller tables with not more than 5 or 6 conditions in each table. But then sequencing is implied when you have a, because those tables are in a tree now, one after the other in some order. Okay. For isolating conditions and actions, DTs are best, and they are not good for sequencing, and for checking completeness, contradictions and so on, it is the best methodology. Decision trees are good for isolating conditions and actions. They are best for sequencing conditions, but they are not very good for completeness checking and so on. Okay. So, it is somewhat similar to the it is more concise than process specification, but it has got disadvantages. So, depends on the taste. When some managers prefer decision trees because they can actually look at the picture of what decisions are being taken in some order and so on. But it depends, as I said, it is purely a question of taste. But when it comes to the correct proof of correctness and so on, and if you have a complex set of rules, nothing like DTs, you have to use them. Okay. They are very complex set of rules, and you want to really be sure or prove the correctness. So, that is the reason I spent a fair amount of time in the lecture, because many books kind of gloss over it. They do not talk about the aspects related to the proof of correctness, okay, which I believe is important, because rules are becoming complex all the time. Okay. So, the final conclusion you might say, or suggestions to you, is that use structured English if there are many loops and actions are complex. Looping is very easily represented in a process specification, while loop and do loop and things like that. Okay. Use decision tables, there are large number of conditions to check and the logic is complex. Use decision trees and sequencing conditions important, and there are not too many conditions to be tested, okay, and then use this. So, this is essentially the final advice you might say at the end of this module, in terms of 3 different techniques that we have described and when to use each one of them. Okay. Now, having completed this module, I will now start on the next module. Next module is an important one, which is on data input methods, and I am going to divide up my discussion into a number of different parts. One is I am going to talk about what is known as data dictionary, how it is developed and used, and then about data input methods, how to input data, batch data as well as interactive data. When I say batch input, like it is like you know, the few days ago the results of you know, CBSE and other exams are announced, where the number of candidates who take the exam is runs into lakhs, 2 lakhs, 3 lakhs, 4 lakhs and so on, and state boards runs into tens of lakhs. Okay. In that case, it is a batch which you use, and the batch is taken together, and the batch, in other words, all the you might say the marks sheets which are entered by manually are given to a data entry operator. He enters the data on the data entry machine. Okay. So, that is what is meant by batch. And interactive means there are situations like for example, point of sales. In other words, in a supermarket, when you purchase some items, okay, the girl at the counter will just enter the name of the article and the amount, the quantity you bought, price per unit, and the total amount, and then it will total at the end. Okay. So, this is interactive, while she enters it for each item as it comes, and then gives you immediately a bill. Okay. That is interactive. So, the methods that are used for batch entry are somewhat different from with interactive entry, because interactive entry you need to have feedback immediately if there are any errors made. And coding techniques, which is very important for determining the uniqueness of data, particularly key data representation. So, these are 3 major topics I am going to cover. The goals of these talks is that in other words, we have to ask the question, why do we need data dictionary for an application, okay, and how do you develop data dictionary for an application, okay. And in the part of the how to, we are to learn about design of forms and screens for data input. Okay. Data dictionary is a raw material from which I start, and that raw material is used in the data input. And so, design of forms and screens, the forms are normally used for batch, and screens are used for interactive. Need and methods of, how to code data elements, particularly key data elements. Why do we code it? And what are the coding schemes which are there for automatic detection of errors, because detection of errors while you enter a key code is extremely important, and if any mistake is made in the entry of a key code, that can lead to havoc in terms of the rest of the system. So, automatic methods of checking any error in the key entry is normally used, and one would very much like to have a system where it also corrects, that if you enter the wrong one, it detects and corrects. But it is possible, it is not impossible to do that, but it turns out that if you want to do a detecting and correcting, the number of redundant digits you have to use to be able to correct becomes quite long, and so total length of the field becomes long, and so the possibility that the correction digits also somebody makes a mistake arises. So, this system must be such that if the error is made in any place where it is a correction digit or a true digit, still it should be corrected. Okay. So, that is what makes it very complicated. Okay. In binary systems, for instance, there are error detecting and correcting codes. Hamming code is a common code used for Hamming parity check codes are used for error detecting. Okay, because the number of ones are either odd or even and just count. Okay, and parity is used all the time in digital computer design, and there are error detecting and correcting methods, where if the error is made in more than one bit, then you automatically correct it. Okay, those are used in a certain kind of situations automatically by the computer. Okay, particularly in areas like long distance communication, where a set of bits are sent and there is a lot of noise in the atmosphere. Okay, then when what is received, they automatically correct it before using it in anything. See, so there are situations, particularly secret codes and ciphers and things like that, where error detecting and correcting becomes important. So, in this case also one could detect, except that this is not binary. The codes are normally alphanumeric, that means they got letters and digits also in it. Okay, and it becomes a little bit more complicated, but it is possible. In theory it is possible. And so, the need to design input data validation methods. There is, apart from coding schemes, when you enter input data, you have to do validation of the input data, and that is very important. And the validation is important again because of the sheer volume of data being entered. In fact, yesterday my neighbor's girl came crying and said, I got my mark sheet and I got in physics 36 out of 100, and in mathematics I got 126 out of 100. So, obviously there is a data entry error which has been made. Nobody can get more than 126 out of 100. Okay, and maybe 36 is very low, because her marks in other subjects are reasonably high, in which case probably this is also data entry error. Okay. Now, the point really is such an error, when it occurs and it comes to the customer, because in this case the poor girl who has to go back and ask for revaluation, stuff like that, and cough up some money. Okay. But in the case of customers for whom you are doing this work, if you make some such stupid errors, he is going to kind of terminate your contract. Okay, that your data entry is so bad that I can't trust your system. Okay, so it is extremely important in while inputting large volumes of data to have automatic methods of checking and eliminating such stupid situation like getting marks above 100 when it is not possible, or getting very low marks when marks in the other areas are reasonably high. So, these things should be pointed out right at the time of entry. Okay. So, that they can be removed before they become too dangerous. Then too dangerous in the sense that if they are used later on somewhere else, then it can become dangerous. In this case, of course, it is, as far as the girl is concerned, it is very dangerous for her, because she has a sleepless night. I mean, sleepless nights, and have to give money for revaluation and so on, which is not good at all. I mean, this is really a bad kind of a system design which has been done by whichever board does this. Okay, they have done it in a hurry, they have not done a proper job. This occurs is not an isolated case. Year after year this seems to be occurring. So, I think it is very important and responsible, a very responsible systems analyst and system designer should really make sure that such stupid errors do not ever occur. Okay, because the entire credibility of computer based systems will be lost, because general public will start saying that even when they truly get low marks, they will say the computer gave me low marks. Okay. So, that effectively is a reason why the credibility about computerization will be lost. It is very important. It is a social responsibility on the part of all of us who do the system design and systems analysis to make sure that such things never occur. So, it is during systems analysis it is essential for an analyst to decide the necessary and sufficient data for designing an application. Okay. So, this is obtained from the data flow diagram. Data flow diagram tells you what data enter a system, what are processed, what are in files, what are output and so on. Okay. And individual data elements of data flows and stores can be cataloged, and this catalog is a description of all the elements. It is a tremendous documentation aid. You can detect at this time any duplicated data, missed data and things like that, and it is a very good documentation aid, and it is very useful while designing system. Later on, if somebody is going to modify your system, this dictionary is going to be extremely useful, because at a glance the meaning of that data will be in the dictionary. Okay, some data item you would have used, unless the meaning is obvious to a person who is going to maintain a program written by somebody else, then he will have great amount of problem to maintain that program. And I say in computing, maintenance is one of the major issues. In fact, companies make money on maintenance year after year. So, maintenance is normally done by a person who did not develop the system. So, developer has a responsibility to catalog. So, it is an invaluable documentation aid. It is such a catalog is called a data dictionary. It is actually a metadata, there is data about data. Normally it is called metadata. Okay. That is, the dictionary tells about what data is used and what is their meaning, and also more details about the data. Okay. So, it is data about data. After data dictionary is designed, one needs to determine how the data has to be input. Okay. The input methods are got to be looked at. Data input methods depend upon whether it is forms filled by customer, or in this case the case of exams and so on by clerks, or they are input manually by operators. Okay, interactive. We thus need to understand both these methods, both the batch inputs as well as interactive inputs. Unless data is correct, results will be unreliable, that is obvious. I mean, and the information system normally have a large volume of data. This is what is the reason why we need to have a foolproof method of checking or controlling the input data. Okay. Because a large volume, special controls are needed to ensure correctness of data input. Otherwise, it is difficult to find out which data is incorrect after the event. See, if you have processed 4 lakh answer, 4 lakh entries you made, and then you suddenly found some error, nobody can go through manually all that 4 lakh to find out where the error occurred. Okay. And so, it is very important to have methods whereby the tracking of errors and the origin of the error can be found out. Okay. So, this tracking is extremely important. Important to design appropriate data input methods to prevent errors during entering data, and also said tracking if any errors actually occurred. Now, you try to prevent it, but sometimes in spite of all your best efforts, some errors would enter. Okay. And in this case, if the error entered, you have to be able to track where it occurred, and you have to be able to change it. Okay. So, tracking is as important as detecting. key data elements are extremely important to identify records. Like for instance, if you are looking at student examination results, the key element is roll number. Roll number is the key element, and if any error is made in the roll number and the two roll numbers are equal, then obviously you have a real difficulty at the last moment. Okay. And so two roll numbers cannot be equal, okay, obviously, and they should be unique. And the uniqueness also, it kind of is an item which makes a difference in terms of, based on that roll number you are going to print out the mark sheet. If the wrong roll number is there, the wrong mark sheet will be printed. Okay. So, that is very, very important to be able to make sure that key data elements, no errors occur. So, you have to code them in such a way that they are unique, concise, understandable by users, and also if they should have some correction capability. In other words, if you can at least detection, if not correction, you should be able to detect any error in a key data entered, in roll number particularly. If first of all you try to prevent it by the proper design, and after doing a proper design and preventing it, if it happens during data entry, you got to be able to point out that error has occurred right at that stage itself, not at the end of the game. Okay. So, that is also important. So, detecting is important. This is the reason. So, now the first topic is about what is data dictionary, and data dictionary essentially is a catalog of data used in applications, their names, types, and their origin, where they occur. As I said, it is data about data. Data dictionary gives a single point reference of data repository of an organization. This is an important documentation which would be of useful to maintain a system. This is where I said them earlier, but I am essentially repeating them to reinforce it, and this is where I will stop and will continue next time from this point onwards.